This is section 5.2. We'll be covering power to a power, power to a product, and power to a quotient. Power to a power rule states that you have an exponent and you're taking it, multiplying it by another power. So this is where you see x to the a power all to the b power. When we do this, the shortcut would be to multiply our exponents. Usually the clue to multiply the exponents are when you see a parenthesis and you have an exponent inside the parenthesis and an exponent outside the parenthesis. It's then that we multiply our exponents. So for instance, if I have, here's the long drawn out way. If I have n to the third power, that means n times n times n, and I square that, that would be me replicating it 2 times, n times n times n, times the quantity of n times n times n. This makes n to the 6th power. The shortcut version would be to multiply the exponents inside the parenthesis times the exponent outside the parenthesis. N to the 3rd power times the 2nd power equals 6. N to the 6th power. Please write the notes above. Make sure you have the rule. And let's try one together. So y to the 3rd power, the quantity of y to the 3rd power to the 4th power is equal to y to the 3rd power times the 4th power, which simplifies to y to the 12th power. Now stop the recording and do the next 3 questions. Now check your work. Number 2 is n to the 3rd power times the 5th power, which simplifies to n to the 15th. Number 3 is t to the 2nd power times the 3rd power, which simplifies to t to the 6th. Number 4 is k to the 14th power. Power to a product. Product is when you have 2 things multiplied inside a parenthesis, and we're taking them to a power. That means everything inside the parenthesis is to the nth power. So this would happen when, say, we have a coefficient inside our parenthesis. So if I have 3x, the quantity of 3x inside the parenthesis, I'm taking 3 to the 2nd power and x to the 2nd power. This simplifies to 9x to the 2nd power. Now stop the recording and do the next 3 problems on your own. Now check your work. 2 to the 3rd power times y to the 3rd power simplifies to 8y to the 3rd power. In number 3, watch out for that negative. So inside we're taking both the negative to the 2nd power, the 5 to the 2nd power, and m to the 2nd power. So negative 5 to the 2nd power times m to the 2nd power is 25m to the 2nd power. Number 4 would be 16, 4 to the 3rd power times t to the 3rd power, and 4 to the 3rd power makes 64t to the 3rd power. I'm going to make it a little bit more complicated. Remember, everything inside is to the 4th power. So negative 2 is to the 4th power times a squared to the 4th power times the 4th power times b cubed times the 4th power times c to the 4th. Well, c was really to the 1st power, so it's multiplied by the 4th. And that simplifies to 16 a to the 8th, b to the 12th, c to the 4th. Now stop the recording and finish the next two. Now check your work. Now, 8 is not to a power because it's not inside the parenthesis. Remember, the base of that exponent is only what's inside that parenthesis. So only inside the parenthesis is what gets expanded to the second power. And it's outside the parentheses that the exponents get multiplied. So it's negative 8 times n to the third power times the second power times p to the fourth power times the second power times t to the 0 times the second power. When I simplify it, I get negative 8, n to the sixth, p to the eighth. Now t to the 0 times 2 really makes t to the 0 power, and anything to the 0 power is equal to 1. So that's times 1, so it would really just be negative 8n to the sixth, p to the eighth. Now try some more. Pause the recording and finish the practice problems. Now check your work. Number 1 is 9a squared, b squared, c squared. Number 2 is 25x squared, y squared. Number 3 is a to the 12th, b to the 6th. Number 4 is negative 64, x to the 3rd, y to the 3rd. Number 5 is negative 32, r to the 15th, s to the 10th. Again, remember, the negative is not part of that exponent's base. So it's negative 49 m to the 6th n squared. Practice some more as they get lengthier. Take a minute. Remember, first we're going to start with the first term. It's 3 squared times x to the second power times the second power times y to the third power times the second power, which comes to 6. 9 x to the fourth, y to the sixth. And now remember, we can multiply unlike terms, so we can now multiply our coefficients together. Our x to the fourth, now we are, since I have x to the fourth, it's not inside parentheses, and x to the second, we go back to our other rule of adding the exponents. Okay, and y to the sixth plus y to the fourth is y to the 10th. So now we're mixing two rules. Now you try the next one. Check your work. Answer is negative 32a to the 9th, b to the 22nd, c to the 2nd. Now we're going to get into power of a quotient. Quotient is a division problem. So when I have a fraction inside of parentheses with an exponent outside, remember, whatever's touching the exponent is the base. So everything inside the parenthesis is to the a power. So in number 1, we take the coefficient to the second power, x is to the second power, and 5 is to the second power. So 2x squared would make 4x squared, and 5 squared is 25. Number 2. Take a minute and try this problem on your own. All right, now check your work. 5 is squared, a to the second power times the second power, b to the fourth power times the second power, and 3 to the second power. Simplifies to 25 a to the fourth, b to the eighth divided by 9. Now you practice. Put the recording on pause and answer the following questions. All right, now check your work. All right, now pause it if you need to check your answers further. Actually, let me read them to you. Number 1 is y to the 20th over 243. Number 2 is 8a to the 21st power over 125. Number 3 is 4/9, a to the 8th, b to the 4th. And number 4 is 16a to the 4th, y squared over 49a squared. So now we're going to mix all of our rules up, and we are going to justify our reasons and what allows us to do that particular step in the mathematic process. All right, so step 1, when I have 3x squared, the quantity of 3x squared, we're going to use our power to a power property and make that 9x to the fourth power times 5x. Minus, what do I do in the next step with 2x to the fourth times x? Now what you should be doing on the right is telling me what rule we use to change 2x to the fourth power to 16x to the fourth power. I should say the quantity of 2x to the fourth power to 16x to the fourth. That's right, we used a power to a power rule. Next step, we multiply our unlike terms on each side of the subtraction sign. And now only if and only these terms are alike are we allowed to add and subtract the terms. Remember, we can only add and subtract like terms. We can multiply and divide unlike terms, but we can only add and subtract like terms. Now you try a couple. Check your work. Answer is 31, a to the 8th, b to the 4th, c to the 6th. Remember, step 1, we're taking our powers to the power. Step 2, we're multiplying our common bases. And step 3, if they are like terms, meaning each variable has the same exponent, then we can add or subtract the coefficients. And that's the lesson for today.